The next two problems are asking us to evaluate some expressions. So we are going to plug the value of y equal to 4. So 4 will go into every value for y. So let's go ahead and plug that 4 in for y. And it also says we're going to use z equal 2. So for every z, we're going to substitute a 2 in for this z and a 2 in for that z. So let's go ahead. 4 will go into this y. Now I have z, and we know that z is 2. And now plus z squared. So 4 times, now I have order of operations here, 2 plus 2. So the parentheses are first, so that's 4. And I have 2 squared. So I have 4 times 4 is 16, plus 4 is 20. Next problem. It says z times y over z, and y is 1, and z is, basically this is 2, that's 5 halves. Okay, so let's go ahead. Let's substitute in 5 halves for z. Times, now I got y, and z is 5 halves. Okay, so let's go ahead and work on this one right here, because this is a fraction unto itself. So what I'm going to do is, remember, what you can do is you can take and multiply the numerator and the denominator by the reciprocal of the denominator so that the denominator goes away. So let's take 5 halves times, and I'm going to express 1 as 1 over 1. And the denominator is 5 halves. And now let's take this fraction times the reciprocal of the denominator in the form of 1. So that would be 2/5 all over 2/5. Okay, so what I'm really doing is I'm multiplying this term by 1, but watch what's going to happen. The denominator is going to be 5 times 2 is 10 over 10. So the denominator is going to become 1, and I can forget about it. So once again, how you get rid of a complex fraction, a number of fraction over a fraction, is multiply the fractional term here by the reciprocal of the denominator in the form of both the numerator and the denominator multiplying by the reciprocal of the denominator. So what we have here now, we're going to have this 5 halves times 2/5 will become 1. So basically I'm going to have 5 halves times 1 over 1 times 2/5. This multiplication, well, let's go ahead, 5 halves times 1. That's going to be 5 halves times 2/5. That's going to be equal to 1. Next problem is the distributive property. So this 3 will multiply by a negative 10. That's negative 30. The 3 will then multiply by a minus 5p. That would be minus 15p. And then I have this minus 8. So combining like terms, I only have one p term, so that's a minus 15p. And the negative 30 and the negative 8 would combine. Next one. Let's take 5, multiply it by 8. 5 times 4p. Now the subtraction will distribute to the 7. It's minus 35, and the minus 5, or subtract 5, will also multiply by the minus 7. That would be plus 35p. Let's combine like terms, 20p and 35p. That's 55p, and I have 40 plus 35. So let me check this again. 40 plus 35. Oh, 40 minus 35. Sorry, 40 minus 35 would be 5. Write an expression for the perimeter of a rectangle with a width of x minus 3 and a height of 10x. Make sure you simplify the final expression. Let's draw a rectangle. And it has a width of x minus 3. So this side is x minus 3. And it has a height of 10x. So this side is 10x. And it says the perimeter. Okay, so those are all going to add together. So basically that would be 2 times x minus 3 plus 2 times 10x That would be 2x minus 6 over here. Over here would be plus 20x. So 22x minus 6. Okay, unit analysis. Okay, so what we have to do is we want to convert 125 feet per second to kilometers per hour. So what we have is, let's think about this. We're going to have, and I'm going to go ahead and put my first term here, feet per 1 second. So my feet are going to have to convert to kilometers. And I'm going to need some conversion factors to do that. So one of the conversion factors is 5,280 feet in a mile. And another conversion factor would be 1 mile is equal to 0.62 kilometers. All right, I also see that I have to go from seconds into hours. So seconds to hours, so I'll need some conversion there, and that would be 3,600 seconds in 1 hour. Okay, so let's use those conversion factors to get the answer that I want. So I start out with 125 feet in 1 second. And let's get rid of the feet first. So let's look at my conversion factor. I have 5,280 feet in 1 mile. This feet unit is a numerator, so to get rid of the feet, it would have to multiply by the feet as a denominator. So let's take that conversion factor and spin it. So I have 1 mile all over 5,280 feet. So now I have feet as a numerator, feet as a denominator, and those are going to cancel. So now I have miles per second. Well, that's still not what I want. I want kilometers per second. So here's my conversion factor over here that relates miles and kilometers. Since miles is a numerator, the miles that I'm going to use in my conversion factor better be in a denominator position. And the 0.62 kilometers would then be up in the numerator. So once again, my miles as a numerator cancel with the denominator. And right now I have kilometers per second as my unit. So let's go ahead and get the seconds to convert to minutes. So seconds is the denominator. Here's my conversion factor. I'll want to write the conversion factor so that the seconds is a numerator. And so I've set my problem up, and we can see that these seconds would cancel these seconds, and sure enough, my end units is kilometers per hour. So when I actually start working this, you're going to take the numbers and multiply them together. So that would be 125. I made a mistake in one of these conversion factors. I'm going to go back and correct it. You can see that the conversion factor is 1 mile for every 0.62 kilometers. That's actually not right. The actual conversion factor, and I have it over here, is there are the conversion factor should be 0.62 miles per 1 kilometer. Okay, so that's the conversion factor. So I'm going to need to switch this conversion factor out here to be correct. I still want kilometers per mile, but the conversion factor would look like this. Okay, so once again, remember I had miles as a numerator, so miles has to be a denominator in that factor. So that would be 0.62 miles and 1 kilometer. So there's 1 kilometer is 0.62 miles. So now we're going to go ahead and multiply across. So it'd be 125 times 3,600. That would be my numerator, the number part. The denominator would be 5,280 times 0.62. And my units, and let's go ahead, those miles would cancel out from this miles. I'm going to have kilometers per hour. Now the next step would be to actually do this multiplication. 125 times 3600 divided by 5280 divided by 0.62. And if you work that out, let me go ahead and stop it for a second while I do that calculation. I got 137.5 kilometers per hour. And that's, I believe, is the end of that page. Let's see. Nope, there's a couple more. Okay, so the next one says solve these equations. So now in this case, I'm going to need to find the value of x that makes this true. So one thing that I can do is when I have an equation is I can do anything to one whole side if I do the same thing to the other side. So let's go ahead and distribute. I'm going to have a negative 2 times 5x, that's a negative 10x. Negative 2 times a negative 2 would be plus 4. A minus 5 times 6 would be a minus 30x. A minus 5 times 2 is a minus 10. It's equal to a negative 46. Okay, let's combine the x portion. So I have a negative 10 and a negative 30. And the numbers would be a positive 4 minus 10. So negative 46. Okay, so we're going to add 6 to both sides. I get a negative 40x is equal to a negative 40. Divide both sides by negative 40. I get x is equal to 1. And we could check that by substituting it back in for x to see if it's true. Actually, we should usually do that, but I'm not going to do that because of time on the video. Okay, now the next problem is an equal to, and it has denominators. And like I said in class, although you can give these a common denominator and solve it, it makes it really time-consuming, and most students somehow don't get the right answer. The best way to work this is to eliminate the denominator by taking it times the common denominator. Take both sides times the common denominator. You can do that because there's an equal to sign. I can actually take this side times some value, and if I take the other whole side by the same value. So the first step, and this may take some space, so let's move this over, will be to convert everything into improper fractions. So I have a minus 25 over 4 plus 4n all over 3 is equal to 3n over 2 minus 8n all over 3. Now what I'm going to do is find the common denominator for the 4, the 3, the 2, and the 3. And that's going to be 12. So what I'm going to do is I'm going to take both sides by that common denominator. And that's going to eliminate the denominators for me. So I'm going to take this side times 12. And I'm going to take this side times 12. Okay, so when I multiply the 12 into this term, I'm going to have 12 times a negative 25 all over 4. Plus 12 times 4n all over 3. On the other side, I would have 12 times 3n all over 2 minus 12 times 8n all over 3. Now what's going to happen is my denominators are all going to divide evenly into this LCD that I just multiplied by. So let's go ahead. The 4 would divide into the 12 3 times. 3 divides into 12 4 times. 2 divides into 12 6 times. 3 divides into 12 4 times. So what I'm actually going to have here is I'm going to have 3 times a negative 25. That's a negative 75. I would have 4 times 4. That's plus 16n. Over here, I have 6 times 3n. And here I have 4, and that 3 canceled into the 4. 4 times 8 is 32n. Okay, so let's go ahead and work this out. So I have to save time, I kind of worked some of the math out. So remember, we multiplied by the LCD right here, And that got rid of all the denominators. I ended up with this expression, or this equation right here. So what I did is I moved all of this up over to this side. And what I did is I added 75 to both sides. So adding 75 to this side makes the 75 go away, and I would have plus 75 on the other side. So this is what I'd have. 16n minus 4 is equal to negative 14n plus 75. I now would add 14n to both sides. So if I add 14n here and 14n here, I get 30n is equal to 75. Divide both sides by 30. And now simplify by dividing the numerator and the denominator by 15. I get n is equal to 5 halves. Okay, that's the end of this page.